unfortunately, I'm not going to really have time to go slow through this. So if you have questions or don't understand something, you're just going to have to go back and watch the recording and pause because, like, I need to get through a lot. I'm sorry. I'm doing it that way. You find the recording on Schoology in the unit at the bottom of the Schoology page. Setting us up for failure. Well, ooh, you just triggered me a little bit there. Like, holy hell. I could not record. Oh, it's okay. It's okay. It's okay. All right. So I am going to go through these. Now we have in many years simplified radicals, so this should be a review. Uh, I like to do simplified radicals by using a factor. I kind of think of what perfect square is a factor of the number I'm trying to simplify. So here, this one is easy because 4 is a perfect square. So how does this simplify down? Oh, well, when you put it like that. Yes, exactly. Square root of 4 is 2. Now, is it only 2? No, it's plus and minus 2, right? Plus or minus 2 squared would give you 4. So the square root of 4 is plus or minus 2. What about 8? What perfect square can go into 8? Yes. So what you do is you take those factors and you square root both. What is the square root of 4? 2. And then can the square root of 2 be simplified? So you have plus or minus 2 square root of 2. What about 180? Does anyone know a perfect square that goes into 180? The biggest perfect square that goes into 180 is a factor. I'm asking for facts that multiply to give you 180. No, neither of those are perfect squares. Yes, but there's a bigger one. Yeah, 36, 36 times 5 gives you 180. You square root both. What's the square root of 36? And then can 5 be simplified any further? So you have plus or minus 6 square root 5. And all of the U practices I am not going to do, but on my TV that I'll post, the answers will be there if you want to practice that. All right. So now we're going to simplify radicals inside of rationals or function. Sorry, or fractions. So here in our examples, you can never, ever, ever leave a square root in the denominator. All right. Does anyone know how you can get a out of the denominator? So squaring it would actually change the size or the magnitude of the value. Yes, exactly. Multiply both the numerator and denominator by the radical, which means we're basically multiplying by a fraction equivalent to 1. Square root of 3 over square root of 3 simplifies down to 1. We're not changing the size, the value of my fraction. So I can do this. This is legal. So I have anytime you're multiplying a whole number times the radical, it's just the whole number next to the radical. And then what happens? What is square root of 3 times square root of 3? Yes, it's just 3. Just 3. Right? Because anytime you're multiplying a radical times the radical, you multiply the number side. So 3 times 3 is 9. Square root of 3, I'm sorry, square root of 9 is 3. All right. So here, oh, I'm going to skip this one. I'm going to go right to this one over here. So what do I do to get rid of the radical in this number? Or instead, I want to get rid of this big fraction. How did we learn last unit we can get rid of this? Math getting really. This is nothing compared. I'm sorry. Multiply by the reciprocal. Yes. We know that this square root of 2 is over an invisible 1. It's over an invisible 1. So we have 3 over 2 times 1. Oh gosh, what am I saying? 1 square root. Now we can multiply this by the square root of 2 over the square root of 2, which in the denominator, what would we end up here on this second? A 2. So it's going to be 3 times the square root of 2, which is just 3 square root 2 over, remember this denominator is 2, so it's 2 times 2, which is 4. And can that be simplified any further? That's it. That's my answer right there. Okay, so now for the big one. This is weird. On my printed out notes, I don't have, oh, it's because I went down. Okay, now for the big one. So my recommendation, you could do this multiple ways. But my recommendation, like we just did in the previous one, is to try to get rid of the big fraction. So, right? So we multiply by the reciprocal of the denominator. So this becomes 3 over the square root of 18 times the reciprocal 4 over square root of 12. So I'm here. Because we have 2 square roots in the denominator, I'm going to, from here, recommend you try to simplify your radicals first before multiplying by the radical. So first, what perfect square would go into 18? What's the biggest perfect square that goes into 18? Yes. So we square root both, and we end up with 3 square root 2 in that denominator. What about, let's do different color. What about for this next one? What's the biggest perfect square that goes into 12? Thank you. I always forget to look at the chat. I'm so sorry. You square, oh gosh. Oh my god. Okay. You square root both, and you end up with 2 square root 3. So now, and this is exactly why I said try to simplify the radicals first, because notice what happens. What can you do here? We can do, no. Before you multiply, looking at these individuals, yes, you can simplify these fractions. Look, those 3's cancel. Yes, and look, what's into both 2 and 4? 2 does. 2 goes into 2 once, 2 goes into 4 twice. So, does anyone know what you end up with here? 2 over square root of 6. Yes, because you multiply the insides of your radicals. But, can I leave my answer like this? No, because you have a radical in the denominator. Yes, exactly. So we multiply both the numerator and the denominator by our radical. And here you end up with 2 square root 6 over 6. But there's one more last thing. Yes, you got it. What goes into both the numerator and the denominator? 2. 2 goes into 2 once. 2 goes into 6 3 times. So you end up with the square root of 6 over 3. Don't cry. It'll be okay. And to answer your question, I thought, wouldn't it be plus or minus 3? Because it's asking you to simplify, I see people's faces. People are crying. Not really, but emotionally. So because it's just asking you to simplify, it's not asking you to evaluate. You don't really necessarily need to put plus or minus. Would it be wrong if you did? No, I'm not crying. Would it be wrong if you did? No, but you don't have to put unless it says evaluate. Oh God. So you can just leave it like that. You can just simplify it down. Okay. All right. Again, I'm not doing this practice. You can. This problem is exactly like this problem. So if you want to practice simplifying all of this version, you can do that last one. Again, my answers will be on my website or on Blue. Okay. So what about the plus or minus? So that's what I was just saying, that we were just simplifying these. We were simplifying. We're not being asked to evaluate the answer. So yes, I know it's kind of tricky. If you're being asked to solve, you always need to account for the plus or minus. If you're just being asked to simplify an expression, you don't really need to account for the plus or minus. How do you evaluate? Wait, why? We're not being asked to solve for an equation here. You don't need to account for both plus or minus. Is it wrong if you put plus or minus? No, but it's not necessary because you're just simplifying. It's not wrong. It's just not necessary. Okay. So here is what we're actually learning about today. The previous was review for this. This unit is on right triangle trig. So we are starting trigonometry. So yes, a lot of this, the majority of this, the majority of this is stuff that you learned in geometry. Some of it is new, but not much. So we do, before getting into this, need to review what are called angles of depression and angles of elevation. Now, I don't know if you remember, I did with my kids, I drew this cute little drawing where I drew like a little bird and a little person. And from these, I drew dotted lines that were parallel with the horizon. And if you are the little person down there and you're taking a look up at the bird, the angle from the line parallel with the horizon, from your eye going upward, is called your angle of elevation. Anytime it gives you the angle of elevation, all you need to worry about is that you are going up from the horizon. The angle is depressed because it's going down. So in this picture, we have an angle of depression going down from the horizon, the line parallel with the horizon here. So this is going up, angle of elevation is going up, angle of depression is going down, is going down. And does anyone know what are the angle of depression and angle to each other? Yes. Does anyone know why they're equal? Alternate interior angles. Yes. They're equal to each other because they are all interior angles. Because like we said, both of these lines are parallel with the horizon, meaning they're parallel to each other. So they are alternate, are the same. So they are alternate interior angles. Okay. So now the fun stuff. What time is it? 1:55. Okay. I hope, I pray that you remember a little bit about trig and you remember SOHCAHTOA. Okay. You are going to have to memorize, well, I guess you don't in this setting, you don't have to memorize anything, do you? But SOHCAHTOA is the acronym we use to help us set up these trig functions. Wasn't she in our history textbook? Yeah. She's the cousin of Sekajulina, right? SOHCAHTOA. So we are going to take these trig functions and we're going to apply them to right triangles because it's all about right triangle trig. We're going to apply them to right triangles to find missing sides or missing angles on right triangles. No, not actually. I'm lying. SOHCAHTOA is not a person. All right. So we're given this example, and it says, given all the sides of a triangle, find the values of all six trigonometric functions. So here, if you recall, I hope that your teacher labeled angles using this symbol theta. So theta, if you recall, like kind of like an O and then with a line in the center. This is theta. So here, if this is our angle, theta, we have to label the sides O and H, opposite, adjacent, hypotenuse. So which one of these numbers is our hypotenuse? Yes, if this is our right angle, which really they should have labeled the right angle, if that's our right angle, the angle across from the right angle is our hypotenuse. What about O? Which one would we put an O on? Yeah, opposite from theta. Opposite from theta is 32. What about A, adjacent? Yeah, it's the only one left. Adjacent is the one adjacent to our angle. It's the one right next to the angle. So now that we've labeled these with OA and H, it's going to be very simple to find the trig function. So if we're, and I'm going to write it right here. If I'm thinking about SOHCAHTOA, and I'm trying to find sine of theta, I look at the acronym to know which letters. So I'm dealing with sine. I look at SO. So has SOH, meaning that our ratio is opposite over hypotenuse, O over H. So which one was our O? 32. So we have, yes, 32 over the hypotenuse, which was, and unfortunately, we always have to look and simplify. What does 32 over 40 simplify down to? 4. Wonderful. Then we do cosine of theta. Cosine is CAH, adjacent over hypotenuse. Adjacent, our adjacent length is 24, and our hypotenuse again is 40. What can this simplify down to? Yes. And lastly, from our three main trig functions, Tangent is TOA, which is TOA, opposite over adjacent. Our opposite is 32, and our adjacent is 24. So what does that simplify to? Yeah. Okay. I know you're really, I don't hate you for saying, I'm really sorry. It just means that you've seen it in the past. Okay. So this wasn't new knowledge. However, you have never been taught these other three trig functions. They are called our secondary trig functions. Okay. Now, the acronym that you use to help you find these three trig functions is CHO, SHA, whoops, COW. Now, do you have to work as hard memorizing this? No, because each one of these secondary trig functions relate back to the original, one of the original three. So if you're looking at these, let's name this CSC is technically cosecant. Which one of the original three do you think cosecant relates to, and why? Yes, Y sign. What do you notice? Exactly. So when you're trying to find cosecant, all you have to do is take the sign and find the reciprocal. Now the next one is secant. What do you think this relates to? Yes, cosine. Again, you just find the reciprocal. Oh my God. And lastly, this COT is cotangent. This one is easy to remember which one. Cotangent is the reciprocal of tangent. Now, the hardest part about these secondary trig functions is remembering which one cosecant relates to and which one secant relates to. How I remembered it, which you can find a way to memorize it that suits you best, but how I remembered it is the letters are backwards. So cosecant, because it's C, starts with a C, relates back to sine. And because it starts with an S, it's backwards, so it relates back to cosine. I just remember the letters of, again, you guys are kind of looking out at the beginning of the year. You can have these notes during the test. Remember which one goes with which. I didn't tell you that. Okay. So again, do you really need to memorize this toe shuck out? No. Did I memorize that in high school? No. I just remembered, okay, secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. So let's go ahead, now that we know this about these secondary trig functions, let's go ahead and find cosecant first. So what do you think the ratio is for cosecant here? Yeah, 5/4. What about tan? 5/3. And what about lastly cotangent? Yes. All we're doing is taking the original and writing the reciprocal. Any questions on six trig functions? Aren't secant and sine the same thing? No. No. I don't know how they're clearly not. Look at secant of theta is 5/3, sine is 4. Okay, so let's go ahead and do this example. Should I do this one? Yeah, I guess I do. It's a different type of problem. Now it says, given that cotangent of theta is equal to 5, evaluate the remaining 5 trig functions for angle theta. So my suggestion to you, anytime you're dealing with trig and there isn't a picture drawn, you need to draw a picture. You have to. Well, I mean, you don't, but it's highly recommended. Okay? So oh, I'm gonna draw a right triangle. Oh, there we go. And I'm gonna put my right angle, and I'm gonna put theta in one of the two leftover corners. It doesn't matter which. And it says that cotangent of theta is 5/12. Now remember, cotangent is associated with tangent. Oh, that's not good. And tangent we know is TOA, O over A. So instead of this being O over A, what's this going to be? A over O. So I know that the adjacent side to this angle is 5. And I know the opposite side to that angle is 12. Now in order for us to finish the rest of these trig functions, I do need to know what that third side is. Does anyone know the length of that third side? Or hypotenuse? Yes. How'd you guys get that? No, that you're thinking of angles. Right. This is Pythagorean theorem. This is Pythagorean theorem. But you also could have noticed that this is a Pythagorean triple. 5, 12, 15, Pythagorean triple. 3, 4, 5, Pythagorean triple. Either you can do Pythagorean theorem or you can just memorize the Pythagorean triple. You don't have to because you can always use the Pythagorean theorem, which is a squared plus b squared plus c squared. So I'm just kind of shorthanding this because I guess we had a squared plus b squared equals c squared. You don't need to write this squared. I have math here because our a squared is 5. I'm sorry, our a is 5, our b is 12. And then what do I do to get c by itself? What do I have to do here? Yeah, square root both sides. So I just remembered any time that I'm trying to find the hypotenuse, it's the square root of the other two that's added to them squared. But you could do the full Pythagorean theorem if you wanted. So the square root of 5 squared plus 12 squared is 13. So that third side is 13. So then I'm just going to label these sides so that it's easy of writing the rest of the functions. We have 5 is our A, 12 is our O, and 13 is our A. So if I'm trying to find sine of theta, sine is over h, what do I end up with? Yes. What? Someone please tell me cosine. And what about tangent? Yeah. Wait, no. Yeah, 12 fifths. What about cosecant? Whoa. What the heck? I just right. Anybody? Cosecant. Yes, 13/12. I just took sine and flipped it. What about lastly? Because we already had cotangent, so I just need to do secant. What do I get? Yes, thank you. Thank you. Okay, it is 155. I am going to stop here. Now it's asking us to solve for this common triangle where we have 5, 12, and the 5. So here it wants us to not only find the missing angles, but also the missing. Now the side is easiest to solve for because we know this is a right triangle, so we can just apply the Pythagorean theorem. So first thing I'm going to do up here is find the length of AC, which I don't know how familiar you guys are with the Pythagorean theorem, but instead of writing this whole thing out, a squared plus b squared equals c squared, you know that you're missing either a or b. So what you can do is square root of your hypotenuse squared minus other sides. Which if this is too much for you, of course you can still do a squared plus b squared equals c squared, da da da, da. But then you notice, okay, so you're just subtracting 5 squared over b squared equals 12 squared, 5 squared, square root both sides. Oh, that's exactly what I wrote up. So what does anyone know? And we want to leave it in simplest radical form. We do not, because that's what math exam wants. We do not want a decimal. So what is, does anyone know, 12 squared minus 5 squared? Should have probably had my calculator up. Shoot. All right. So we had 12 squared minus, what was it again, guys? 5 squared? Yes, 119. Now, does anyone, whoa, does anyone know, does a perfect square go into 119? No. So that's it. As simplified as that radical gets, we're lucky here. So it means that this third side, oh, uh, is 119. Square root, sorry, radical 119. So now we found the third side, but we still have to find the other missing values, the measure of angle A and the measure of angle B. So I'm going to first find the measure of angle A. Now I know this is way back, but does anyone know what you use when you're trying to find the missing angle using trig? So we are going to go over special right triangles. We don't know that this is a special right 30, 60, 90. We have no idea what these angles are. And in fact, I can tell you it's not 30, 60, 90. Okay, does looking at this calculator and looking at the trig functions on this calculator and then the values above those functions, does that help you at all? No. Okay, I'll just tell you, I guess. Oh, but really good to point out, we have to, now that we're doing trig, our calculator has to be in degree mode. Do you remember where we harped and harped and harped about your calculator in degree mode? Make sure your calculator is in degree mode. Then go back. So what's you go and press mode and you go down to radian and over to degree and you press enter. Okay. So now, anytime you're missing the angle, which we are missing the angle clearly here, anytime my husband's anytime you're missing the angle, you have to do inverse, inverse trig function. Okay. Now, because we're finding e, it doesn't really matter. Um, it doesn't really matter which trig function we use. You can use sine, cosine, or tangent. I'm just going to go ahead and use sine. So we have, and I guess I should have written this at the What is our trig ratio for the sine of A? Remember, it's so Katoa. So has O over H. So what is the sine ratio? Yes, 5/12. So going back to our calculator, anytime we're missing the angle, which we for sure are here, where the heck is my calculator? It's in this thing. There we go. You have to do inverse function. What? Oh, thank you. We have to use inverse. So we're going to press second sine. And inverse just means that you have that -1 on your function. And then we put in the ratio, 5, and we get 24.62. So that is the measure of angle A, 24.62 degrees. Any questions on that? If you know you're going to forget, you're like, I have no idea how she did that. Write your, oh, let's see here. Yeah, because it's the sine of angle A. We're working at angle A here. In a second, we're going to do the same thing but for B. Oh, actually, no, we don't have to. But because we're trying to find A. If we were trying to find B, we would have said sine of B. What's up? Oh, you could have. I just really because I love sine. You could have used sine. You could have used tangent. I just picked sine. No, you end up with the exact. End up with the. English as inverse. So let me show you guys. Seems like you're looking. Let me show you. Cosine is middle course. So means adjacent for hypotenuse. Our adjacent side here is the square of 119. So because we're doing cosine and we are missing the angle, you have to press second cosine. But this time it is the square root of 119 over CAH. So over H, which is enter. And see, we end up with the exact same thing. Nice easier to explain here because you so that's really why I took time because we're only dealing with the opposite for the one. But it doesn't matter as long as you ratio when you're using the constant opposite thing. Any more questions? Um, it doesn't matter in this case. But you can have a radical magician if you believe it. You believe the answer as a radical magician. Okay. All right. Last week, the reason I said that we didn't use the ratio time B was because the degrees the time was not up to. I really hope, I really hope that you remember that. How triangle? Hopefully everyone remembers 180, 180, 180, 180. So here for the right triangle, I know that this is 90. I know that all I have to do to find the number is 180 minus 90 minus the previous angle, 65 degrees. So all I did to find that was I subtracted it from unity to the 30. Okay, next one. Now this is just a word problem. Let me read it. Lucy is flying over Round Rock High School to scout out where to build building 3500. Plane has a 47 degree of depression, angle of depression, and her elevation is 1350 feet. What is her horizontal distance to Round Rock High School? So she's flying. I'm going to draw a little plane. I don't know why, but I am awful at drawing planes. They always look like goldfish. Like I can't figure out how to draw it better. But that's my plan. And then I'm gonna she's flying, and she's trying to figure out where to build this building, 3,500. It says that her plane has an angle of depression of 47 degrees, meaning from a line horizontal or parallel with the horizon going downward is 47 degrees. And I'm just going to draw a line between her plane and the school. I'm going to draw the ground, and I'm going to draw a line to represent her building. So where should I put that 13? Where should I put 1350 on this? Yes, exactly. Her elevation is like her height to the ground. So it's right, ooh, no, it's right here. Elevation is a synonym for height. It's always going to be perpendicular to the ground. Perpendicular to the ground. Then it asks, what is her horizontal distance to Round Rock High School? Where should I put my X? Yeah, I would put it on the bottom line here. Her horizontal distance is the distance she is horizontally from the school. Anytime it says horizontal distance, you better put X. on a line that is the same as the horizon. Okay, so what is the big issue with drawing besides my off? Can I immediately go in and start solving? What's wrong? The angle that I wrote is an angle outside my triangle. So, yes, I don't have enough information yet. What can I do to make myself have enough information? What did we learn at the beginning of these steps? Yes, your ultimate interior angles. Or you can remember the angle of depression is the same as this angle of elevation down here. So now I have an angle inside of my right triangle and I'm working with two sides. I can solve for x, no problem. So 47 is my angle. I'm just going to quickly label the sides it gave me. So if 47 is my angle, 1350 is my opposite side, and x is my adjacent side. Which trig function deals with O and A? Tangent. So here we have tangent of my angle, which is 47, is equal to total O over A. What do I do to solve this? How do I get x by itself? Forget about, I mean, if you're struggling thinking about this, forget the in here. What would you do to solve this? Right. How'd you get that? Right. Yes. You know, to get something out of the denominator, all you have to do is multiply by the denominator. So this turns into x times tangent of 47 is equal to 1350. But then the x is still not by itself. So you just divide by tan of 47. Or you could just recognize that anytime you have x in the denominator, like someone was saying, like Sam was saying, you can just switch the function and x. I know that when I taught this, I just taught when x is in the denominator, split and divide. So in our calculator now, I just need to do 1350 divided by tan of 47. And you get 12,058 points. Oop, that goes up to 90. Why is it not? And you're done. Any questions? Anyone know what you would have done to access that numerator? Do you remember? Multiply. You would just multiply 1037 times 1350. Okay. Whew. So that was all geometry. Now for something new. You guys, these notes are going to take so long. I don't know if I can get through. But I'm at least going to get through reference angle. I don't know if I want to go over special right triangles right now. We'll see. All right. So now I'm, this is called the standard position angle. What you need to know is that anytime it gives you an angle, so let's draw an angle. Let's do uh, this angle. We'll say it's 120 degrees. We'll say anytime it has an angle, and then it says that it wants you to find the reference angle, what you do is you take your line and you drop a line down that is perpendicular to the x-axis, okay? Like so. That's what it's. A reference triangle is formed by dropping a perpendicular line from the terminal ray, which terminal ray just means it's a end. It's a it's a line with you drop it down to the x-axis. So the reference angle is the angle closest to the origin formed by this reference triangle. So on this picture, that is our what is called reference angle. And our reference angle, does anyone know what is the degree of our reference angle here? How many degrees? Yes. Oh, I'm sorry. Answering there. Yes. That angle theta there, that reference angle is 60 degrees. And you know this because you know that a straight line, like the x-axis is, always adds up to 180 degrees. So if this angle is 120, you would do 180 minus 120, and you get 60 degrees. So from this definition that we just stated above, which one of these triangles, A or B, is our called the reference? B. B. It's always created by going from a point or going from a terminal ray, dropping a line down to the x-axis. So it can't possibly be A, because that's a line to the y. I didn't mean to box it. All right. So in this example here, it says both in standard position and negative 37 is a point on the terminal side of theta. Draw a reference triangle, find each of the missing angles, and use the reference angle to determine each of the 6 trig functions. So this is a lot. This is a lot, but first thing you should always do is draw a picture. Okay, I'm going to draw an x and y axis, and then I'm going to plot the point negative 37, which is way up here. We'll do like there. This is negative 37, and I'm going to draw a line connecting the origin to that point. Should zoom in. Hold on. Okay, so I'm going to, from this point, drop a line down, creating my reference triangle there. And then it says theta is in standard position. This is another way to say that it's the reference angle. So it's this angle right here. Now, how long is the left-hand side of this triangle? 7. Yeah, because that point is negative 7. So this is 7. And then this bottom, we know the length is 3, but technically we do need this as negative. Negative 3. So now we need to find the missing angle, and we also need to find the hypotenuse. So the hypotenuse as always, we can use Pythagorean theorem. Now we're trying to find that third side. So no, it's a and b squared, the square root of them added together. So that's 7 squared plus 3 squared, which is 58. So then let's go ahead and find theta, our reference angle. What am I going to use? I am going to use tangent because then I won't have to deal with a square root at all. So I'm going to use tangent. And remember, anytime we're trying to find an angle, we have to use inverse. And what is my ratio for tangent? Exactly. So, which is 7 over, I think that should be 3. Don't do negative. Where's my thing? Oh gosh. Okay. Grabbing my calculator. I have to use inverse, but don't forget to hit second. Tangent 7 over 3. 66.80 degrees. And then to find this other missing angle, which we'll call alpha, just like before, we know a triangle adds up to 180, so you would do 180 minus 66.80 minus 90, and you end up with 23 degrees. Oh, this is a problem. It's not a problem, it's a big problem. So now we have to find the other, or all 6 trig functions, unfortunately. So we have sine, which, and we're want it in referencing. So we're using 2. That means 7 is our opposite side, -3 is our adjacent, and 8 is our h. So, sorry, the 58. So sine of theta means that we have 7 over the square root of 58. However, can I leave it like that? What does that turn into? How do I get rid of the square root of 58 in the denominator? Right. So what you do is you multiply both the numerator and the denominator by the square root of 58. So that means in the numerator you'll have the 7 times the square root of 58. And then what is square root of 58 times square root of 58? 58. Yes, exactly. So that is sine of theta. Whoops, I was not pretty tight. Cosine of theta is adjacent over hypotenuse, so that's -3. Now it's going to be -3 over the square root of 58 again, right? But what I'm just going to do is I'm going to skip a step, and because I know it's square root of 58, I know I'm going to need to multiply the numerator times 58 and the denominator times 58. Tangent of theta is 7 over -3. Then, because technically that is the value of the angle. So we didn't have to use it, we don't have to use it when we're trying to figure angles because whether lengths are negative or positive, the angle will remain the same. But when we're trying trig function, or sorry, trig ratios, we do have to include the negative. Okay. So now the other 3 trig functions are just the reciprocal. So you look at the original of sine to get cosecant, and you end up with square root of 58 over 7. Secant is square root of 58 over negative 3. And cotangent is negative 3 over. And you're done. Oh my God. I can't believe that we get all of these today. I don't know how the other teachers are getting through all this. So I will finish recording. Like I said, all of special right triangles, all of this is really just looking at the triangles and writing down the ratios. So like here for part A, sine of 30, you know that sine is O over H. So that would mean that O over H gives you 1/2. This is the special right triangle that will always apply when you have a 30, 90 triangle. It will always be in this ratio, 1, 2, square root of 3. And then this is 35, 45, 90 triangle. Again, they will always have this ratio, 1, 1, square root 2. Bearings, again, once you, like, even if you just quickly look at my my answer key online, you'll be able to figure out what a bearing is. It's just like they use this a lot in and they also use it for sailing and use bearings a lot. It's just they're gonna use bearing in homes. So it's just a quick where you need to recognize. And honestly, you could get it from looking at my key. Are there any questions where I want to go? Oh, can you scroll up so we can see the answer? The answer to this. All right. So like I was saying before I released the previous class, special right triangles are either 30, 60, 90 or 45, 45, 90, and they're always in the same exact ratio. On the 30, 60, 90, you have 1 across from the 30-degree angle. 60 across from the 60-degree angle is square root of 3 always, and then across from the 90 is 2. Now these may be in multiples, so you could multiply each one of these by 2. So you would have 2 here, 2 square root 3, 2 times 4. So now back to our example 1 here. We're trying to now find the cosine of 45. So that means we're going to be looking over here now at the 45, 45, 90 triangle. And we're picking, now there are two 45, so it doesn't really matter which one we choose to deal with. So I'm going to choose this bottom one here. And we know cosine is adjacent over hypotenuse. So that means our adjacent is going to be 1, and our hypotenuse is square root of 2. So it's going to be 1 over square root of 2, but we cannot leave that square root of 2 in the denominator. We can't have a radical in the denominator, so what we do is we rationalize it by multiplying both the top and the bottom by the square root of 2, and we end up with square root of 2 over 2. And then in example 2, now we're working the other way. We are trying to find the missing angles. So looking at this first portion, part A, it says the square root of 3 over 2. Now, what I do is I remember, okay, which one, 45, 45, 90, or 30, 60, 90, has a square root of 3 in it with its ratios? Well, 30, 60, 90 does, not 45, 45, 90. So square root of 3 over 2 is this, oh, I'm erasing, this bottom side over this hypotenuse. And we know cosine is adjacent over hypotenuse. So which angle has the square root of 3 as the adjacent? Well, 30 does. So that means our theta is 30 degrees. And then part B, cotangent. Remember, cotangent is the reciprocal of tangent. So tangent is TOA over A. So that means that cotangent would be A over O. And 1 having a trig ratio of 1 means that it is either the same value over itself or 1 over 1. Now the only triangle that has two of the same exact values as the sides is 45, 45, 90, with our two legs of the right triangle being 1 and 1. So that means that our theta has to be 45. And then I'm not going to do the U tries. You guys can practice those. Again, the answers are on IKEA, online, or on Schoology. So now we're just quickly going to be going over bearings. Now there is a standard angle measure that we've been dealing with our whole math career, and then there's what is called a bearing angle measure. Now, you use bearing angle measures with a compass. We use this because it's kind of easier to know exactly which direction you're going versus the standard angle measure. If I just say 100 degrees, you have no idea which direction that is really going unless you're looking at an X and Y axis. So let's draw 100 degrees as a standard angle. So we always start, when we're thinking of a standard angle, an angle measure, we always start on the positive X and we go to our angle and we call this 120 degrees. Now a bearing angle, like I said, is dealing with a compass. So we have north, never eat sour worms, north, south, east, west. And you always are referencing the either north line or north south line. We'll go over in a second the difference between those two, but like I said, you always reference the north or north south line. So that means that instead of saying 100 degrees, you would instead say 100 degrees north. I'm sorry, 10 degrees north, jeepers. So this would be 10 degrees north, you would say. Oh my gosh, I meant this one over here to be 100. I don't know why I wrote 120. So these are actually the same exact angle, just represented differently. All right. So like I was saying a second ago, there are two different ways to state a bearing angle. One is north line only, and this is either acute or obtuse, and it's always starting from your north line, right? This top north portion of the y-axis, the positive portion of the y-axis. Or you can have north-south line, which is acute angles only, cannot be obtuse, and you always put N or S first, depending on which one is closer to your angle. And then comes your acute angle measure, and then after that is whether it's on the east side or the west side of your north-south line. So for example, the bearing of P from O, so this is just dealing with this angle right here. If we're dealing with a north line, if we're writing this in north line notation, from our north line, the angle measure, it says right here, is 65 degrees. So we would say 65 degrees N, 65 degrees north. Or if we're dealing with a north-south line, again, getting to P, P is closer to our north side of the compass, so it would still be north, and we put N first when we're dealing with north-south line, and then we put the angle measure 65 degrees, and then you ask yourself, okay, was it north going east or west? Well, this example, it's north going east, so you put north 65 degrees east. Next example, we have the bearing of Q from O. So we're dealing with this line here. And from your north line, oh, and I forgot to mention, from your north line, you always go clockwise. So just like we went from the north line down to P, 65 degrees, we were going clockwise. Same thing here. From our north line, we go 300 degrees clockwise. So it is 300 degrees away from our north line, going clockwise. I guess we should put that there, huh? Angle measure going clockwise from north line. Okay. So now we are doing the north-south line. So, whoops. So we look at our cue again and we ask ourselves, okay, which one is closer, the north line or the south line? North is. So again, I have north first. And from this north line, we have to ask ourselves, how big is that angle measure there? Well, we know that from this north line all the way around was 300, and in a full circle is 360 degrees. So all that's left over here is 60 degrees. So that's a 60-degree angle measure. So from the north line is 60 degrees, and we went north to west. So it's N north, 60 degrees west, you would say. So now let's try this last example, and then we're done. It says a Boeing 777 aircraft takes off from O'Hare Airport on runway 2 left, which is a bearing of north 20 east degrees east. After flying for 1 mile, the pilot of the aircraft requests permission to turn 90 degrees and head toward the northwest. The request was granted. After the plane goes 2 miles in this direction, what bearing should the control tower use to locate the aircraft? Okay, so like I was saying before, you always want to draw a picture when there isn't one drawn for you. Okay. And then we're going to draw exactly what's happening here. So it says that the Boeing left the airport at a bearing of north 20 degrees east. So that means starting from our north line, north, east, south, west. Starting from our north line, heading east. It is 20 degrees. That's our bearing. So I'm going to draw a line. And from here down to our bearing is 20 degrees. And then it says the airplane, so he flew 1 mile that direction. Then it says he requested to make a 90-degree turn. So I'm going to draw an angle of 90 degrees heading northwest. So that's 90 degrees. And it says that he traveled 2 miles that direction. We should draw this a little longer. That was crooked. And then I'll connect it. And it wants to know what bearing the control tower, which is the center, should use to locate the plane now. The plane's over here. I'm so awful at it. Well, okay. So now we're trying to find this angle measure here, which is, we'll call it theta. All right. So what we need to do is we need to first find this. We need to find this big angle in this right triangle. So we have our adjacent side and we have our opposite side. And whenever we have at least 2 sides and we're trying to find a missing angle, we can use trig. Now the function using O and A is tangent. So I'm missing the angle. So again, I'm going to use inverse. And tangent always has O over A. So I'll have 2 over 1. And I need to pull out my calculator again. And I'm going to use inverse of tangent. 2 over 1, which is 2, is 63.43 degrees. But then, however, notice that that was the full angle down there. That's not the angle that is going to determine our bearing from the control tower. Because remember, bearings always need to start either at the north line or the south line. So that full angle isn't starting at either north or south, meaning we need to subtract away this 20. So theta is actually equal to 63.43 minus that 20-degree angle. So our angle is actually 43.43 degrees. Now we'll practice writing this both ways. First, we'll do from the north-south line, which is always an acute angle. So we're north, 43.43 degrees, headed towards the west. So we put west. Or you can write from the north line going clockwise. That's 360 minus this angle, which is 316.57 degrees north. And we're done. Oh my God.